Hello students, welcome back. So technically students, in this video, we will be talking about the numericals which are based on Upthrust for the second exercise for the part B. Just little bit suggestions, students, for making this exercise much more easier. Now, when I do talk about this exercise, guys, this exercise is that which completely depends upon formulas. So you need to make sure that your formulas which you are going to try, which you are going to learn for this exercise, they should be very much thorough. If your formulas are clear, then you will be in a better position to solve this sum very easily. Okay. Logic is little bit, but more of formulas which will be helping you out to make this sums in a easier format. Okay. So I will first try to share the formulas which we need to try. And then students, we will try to understand how to solve this numericals. Okay. So let us first try to go with the list of the formulas which we need. And then we will try to go with the sums which are required. Okay. So hoping that we all have our books with us. See to it that we are not sitting idly in front of the screen, guys. And let's try to go with the list. So first part, in part B, the formulas which we need, they are related to density. Now, students, I know that density is nothing but mass upon volume, right? This is my basic formula which I need. This density can be measured in two units. First, it can be measured in its SI unit. Second, guys, it can be measured in terms of its CGS unit. When I do talk about SI unit mein the value will be kg meter raised to minus 3. CGS unit will be gram per centimeter raised to minus 3. Now, when I go from SI unit to the CGS unit, that is from kg to gram, I am supposed to divide this quantity by 1000. If I go from gram to kg, students, I will multiply that physical quantity by 1000. For example, if they say that the density is 5 kg per meter cube, converted it into gram per centimeter cube. So I will take the magnitude of density and then I will divide it by 1000. That will give me 5 into 10 raised to minus 3 grams per centimeter cube. This is the first category which you have to take care. The second category of the formula, students, which you have, that is related to relative density. Relative density is a major topic in this part B. To calculate relative density, we have three formulas. Formula 1, relative density is density of the substance upon density of water. Okay, here we are going to relate our physical quantity, or we are going to relate our density with the density of water, students. So your denominator will be density of water. Very important point, relative density will not have any unit because it is the ratio of two same physical quantities. Okay, kids. Second formula which we do have, that is RD is equal to W1 upon W1 minus W2, where W1 represents weight of the object in air. Second, W2 represents weight of the substance or weight of the object in water. To be very precise, guys, it is in water. One more formula we have for calculating RD, where this is the relative density for solid students. The second formula is relative density for the liquid. So relative density for the liquid ka formula is W1 minus W3 upon W1 minus W2. We already know, students, what is W1. We already know what is W2. W3 is something which is introduced. W3 is weight of the substance in a specific liquid. They will give us in the question that the weight of the substance in so and so liquid is this. So that you will denote it by W3. Okay. Now, students, little bit of logic if I try to apply. I know that density is mass upon volume. Same way, relative density would be also mass with respect to volume. So here, this value which you have at the topmost part, that will be the mass of the substance. And the value which I have at the bottommost part, that will be the volume of my substance. Same way, students, your numerator here will represent the mass of the substance, and this denominator will represent the volume of the substance. Okay, getting it, students? One thing which will be taken care, sometimes they do ask us to calculate weight of the object. Weight is m into g, where m represents mass of the object and g represents acceleration due to gravity. Generally, many times they don't give us g ka value. So you will write it as gf, or you will write your answer in terms of kgf if mass is given to you in kg and if mass is given to you in grams. So for grams, you will write your answer in gf. For kg, you will write your answer in kgf. Clear, students? Okay. So these are certain formulas which you will be taking care for solving the sums in this part. I think so. This is the only thing which is supposed to be taken care. If still we will have in between, we will try to solve that. So let's take the first question, guys. So the first question here says density of copper is 8.833 GCM raised to minus 3. Express it in terms of kg per meter cube. So guys, I am supposed to jump from gram per centimeter cube to kg per meter cube. I hope we all know what we are supposed to do. We will take 8.83. We will multiply our answer by 1000, which will give me 8830 kg per meter cube. This is how I'm supposed to solve. Okay, fine. Second question, students. The second question is relative density of mercury is given to me. Express your density in CGS and in SI unit. So let's make a note, guys, what all things have they given us. So first thing, they have given me the relative density. So we will write it as 13.6 is my relative density. Then, guys, just a minute, I'll check whether the recording is going on or not, because this is the second time I'm recording. Okay, sure. So it's recorded and RD is 13.6. I need to express this density, students, in terms of its CGS and in terms of its SI unit. So first from relative density, I'll calculate my density. I know that RD is density of substance upon density of water. 13.6 is equal to ds as it is. Density of water, I'm taking it as 1. If you want, you can take density of water as 1000 also. The choice is yours, guys. There is no hard and fast rule which says that no, you take it in 1 or you take it as 1000. Okay. I will cross multiply, so I get density of solid as 13.6 GCM raised to minus 3. This is what we will try to get it here. Okay. Now, students, when I do talk about this particular part here, I will now use it in my formula. This which you have got, that is the CGS unit. We are supposed to even calculate in terms of its SI unit. So to calculate or to convert CGS into SI, I think we all know what's the trick, guys. We need to multiply our answer by 1000. So density of substance will be 13.6 multiplied by 1000, which will give me 13600 kg per meter cube. Okay, students, this is my SI unit. Come on, let's take the next one, students. Third and fourth, I feel you all should try. It's simple. Density is given to you of the substance. You need to calculate RD. It is density of substance upon density of water. Since here substance ka density is given to you in kg, you will take density of water also in kg. Density of water in kg will be 1000 kg per meter cube. Okay, kids? Similar way, we will try to calculate relative density is given here. density of substance we need to find out. If you want, you can use RD is ds upon dw. dw ka value you can take it in terms of 1 or you can take it in terms of 1000 also. So the choice is yours, guys. Okay, make sense? I hope this is clear to us. Come on, let's try to proceed to the next part, students. So this is how we are supposed to solve this part. Let us take the next thing. The next thing which we do have here is question number 5. Question 5 says calculate the mass of a body whose volume and relative density is given. Sure, let's try the fifth one. Calculate the mass of a body whose volume given to me, I think so, it was 2 meter cube. So we will write here volume 2 meter cube and RD is given to me as 0.52. So students, the trick here is we will first calculate density. Sorry, we will first calculate the density of the substance because from that density of substance we will get the mass. Reason, because density is mass upon volume, right? So to substitute everything here, students, we will try to solve it. RD is density of substance upon density of water. Here, RD I will take 0.52. Substance का density I don't know. Water का density I am taking it as 1000. You must be wondering, sir, why did you take water ka density as 1000? Reason is volume given to me, kids, is in its SI unit. So I will try to take density also in its SI unit. I shift that 1000 there, guys. So we will get 520 kg per meter cube as density of substance. Now, I think I can try to prefer it using in this formula. So when I substitute, I will get density of substance, which is 520, mass as it is, kids, volume is 2. I cross multiply that 2, so I get 520 multiplied by 2. This would be 0, this would be 4, 5 2s are 10. I'm getting 1040 kg as the mass of the substance. That is my fifth one. After fifth, now comes sixth. Sixth one, I think you should try, guys. It's a simple. I'm just giving you a hint. Calculate the mass of air. Okay. Dimensions are given. That means this is volume given to us. Density of air is also given to us, students. We will use the formula density is mass upon volume. Cross multiply, you get your answer. Let's take seventh one. The mass of stone is 113. So I will make a note here. Mass is 113 grams. It is put in a measuring cylinder whose level is 30 ml and 40 ml. So V1 is 30, guys. V2 is 40. I'm supposed to calculate RD. Before calculating RD, I will first calculate density of my substance. I know that density is mass upon volume. 113 upon V2 minus V1, guys. 113 upon 40 minus 30. 11.3 GCM raised to minus 3 is the density of the substance. Now, if I try to see carefully, guys, I know that RD is equal to density of substance upon density of water. 11.3 upon I'm taking density of water as 1, which will give me my answer as 11.3. Does it make some sense to us, guys? Okay, so let's take eighth one. Question number 8. Eighth question says a body of volume weighs 1 kgf in air. Find the weight in water and its relative density. Simple it is, guys. I will first make a note of the things which are given to us. Question number 8. They have instructed the volume of the body is 100 centimeter cube. The weight of the object in air is given. So this is W1. In bracket, I write air so that there is no confusion. I am supposed to find out the weight of that substance in water. So that is W2. We are supposed to get it, students. And we are supposed to find out relative density. So, point one, I will first calculate the density of the substance. So, for calculating the density of the substance, I know that density is mass upon volume, right? So, let's try to first get the mass. They have instructed weight in air is given as 1 kgf. I know that weight is mg. So 1 is equal to m into g. It is technically 1 kgf. That gg will get cancelled. I'll get mass as 1 kg of that object. Now, density is 1 upon volume, guys. Here there is a problem. It is given to us in centimeter cube. We will have to convert it into meter cube. So 100 upon 100 into 100 into 100. Reason why I divided by 100 three times because 1 centimeter cubes is 1 upon 100 meter. If I take cube, I will take cube of this, hence I divided by 3 times. I can easily cancel these two zeros. I'm cancelling the two zeros. Will be, my volume means the volume of the substance would be 1 upon 1, 2, 3, 4. That will go up, which will give me the answer as 1, 2, 3, 4 kg per meter cube. I hope this is clear. This is density of substance. Now, kids, we are supposed to find out RD. To calculate RD, I think I have a formula, which is density of substance upon density of water. Substance ka density I just now found. Water ka density I will take it as 1000. Sir, why 1000? Because if you notice, guys, here it is given to you in kg. Three zeros will get cancelled. We will get RD ka value as 10. Don't stop here. We need to even calculate W2. And if I try to recollect, I have a relation. See, we have a list of a formula which says RD of a solid can be found out by using this particular formula. So let's try to prefer that formula and let's try to get it. So we will write here since RD is equal to W1 upon W1 minus W2. RD is 10. Weight in air is given to me, guys, as 1. Weight in water I'm supposed to find. So I'll write W2 as it is. I will cross multiply. When I cross multiply, kids, I will be getting this thing as 10 bracket 1 minus W2 is equal to 1. So this is 10 minus 10 W2 is equal to 1. I think so this sign, this term should go there and 1 will come here. So I will get 9 is equal to 10 W2. So weight of that object is 0.9 kgf. I think 9 upon 10, so we all know how to solve. Right, guys? So we will get 0.9. So that is the answer, which is weight of the object in air. They have given here to us in GF. We found out in KGF, which was 0.9. I multiply it by 1000. I will reach to the same answer. Okay, students? Come on. Let's take the ninth one. Question number 9 is a body of mass. So this is mass. Completely immersed in water displaces 20,000 centimeter cube of water. Okay. Calculate the weight in water, that is W2 and RD we need to find. I think you all should help me out to solve this sum. Come on. So how are we going to solve? Question number 9. Let's first write what all things are given. Mass of the body given to me is 7070 kg, students. Volume of that body is given to me as 20,000 centimeter cube. I am supposed to find out weight in water, that is W2, students, and I am supposed to find out RD. I think to calculate RD, I will go with my basic formula, which is I'll calculate the density of substance by using mass upon volume. But kids, the problem here is volume is given to me in centimeter cube. So this will be 20,000 upon 100 into 100 into 100. I converted it into meter cube, which was required as per my standard SI unit. Things which are getting cancelled, cancel them. Four zeros cancel. One, two, three, four. I will be left out with 2 upon 100. So this will be 2 upon 100 meter cube. Make sense, students? Now, I use my formula. The formula is density is equal to mass upon volume. So density of substance is equal to mass 70. Volume is 2 upon 100. 100 will go here in the numerator. So it is 70 multiplied by 100 upon 2. This will be 2 ones are 235s are 35 into 100, guys, is going to give me 3500 kg per meter cube. Simple. Density of substance I found out. Now comes the best part. The best part is to calculate RD, guys. We know that RD is equal to density of substance upon density of water. Density of substance is 3500. Water, I will take it as 1000. Reason why I'm taking 1000 because I took this density in kg. So by default, I'll take water ka density also in kg. Two zeros getting cancelled. I solve this thing further. I get 3.5. Chalo, one part is done. Now we need to calculate weight of the object in water. I think guys you can help me out with the formula. RD is W1 upon W1 minus W2. 3.5 is equal to weight of the substance, which we haven't found. Mass is given. From mass, I can calculate weight by using mg. So this will be 70 kgs. Okay, students. So 70 upon 70 minus W2. I cross multiply. I get 35 upon 10 into 70. Wait, I'll try to write it in the bracket, otherwise it will create confusion for you guys. So 3.5 70 minus W2 is equal to 70. I can keep this 70 here alone. Let's not multiply. Let's shift this 3.5 there. This will be 700 upon 35. I think they are divisible, guys. And this is 35 ones are, this is 35 20s are. Wow. So we get 70 minus 20 is equal to W2, which is 50 kgf. That is the weight of the object in water. Simple, guys. I hope we all are on the same track. We all are able to understand what is happening, kids. Great. Please be focused. Please be understand and try to figure out, guys, how are we supposed to solve this thing so that the things are becoming clear and easy. Okay, guys, come on. Let's try to take the next part. After completing this thing, then comes the next part. Oh, wow, this is very easy. 10th one. 10th one is a solid weighs 120 GF in air. So this is W1. 105 in water. So this is W2. Calculate RD. This is easiest somewhere. RD is equal to W1 upon W1 minus W2. Substitute the answer. Same way, this is also there, the 12th one. Weight in air is given W1. Weight in water is given W2. Expecting me to calculate RD, I'll use the same formula. RD is equal to W1 upon W1 minus W2. Easy, guys. Simple. Pakka. Chalo. Let's take the next one. Uh, Wait a minute. Yeah. So we need to try 11th one now. Question 11 is a solid weighs 32 GF in air and 28.8 GF in water. Okay. So these are the things given to me. So let me make a note. I think that was question 11. Yeah. Question number 11. Weight in air is W1, 32 GF students. Weight in water is W2, 28.8 GF. I'm supposed to calculate the volume of the solid. So to calculate volume of the solid, kids, we will use the formula which is W1 minus W2. I hope this logic we are able to figure out. My weight in air is 32. When I jump in water, it becomes 28.8, which means the loss in weight is nothing but my volume, huh, guys? This we had done it in part A, if you remember, right? So 32 minus 28.8. I think when I try to subtract it, it should give me my answer as 3.2. And I will write it as centimeter cube. Reason because if I see my weights are given in CGS. My volume should also be in CGS. This is part A. After getting the volume, students, second thing which was required, I feel, was RD. Here, so now you guys are expert. We know that RD is equal to W1 upon W1 minus W2. So the things which are given to me, I will try to substitute 32 upon 32 minus 28.8. Guys, please don't write the final answer directly. Do the substitution so that suppose in exam, by chance, if your calculation goes wrong, you get marks for substitution. This will give me 10 without any unit. RD has no unit. B part. After B comes the C part. C part is calculate the weight. Now, this is important, something different. Calculate the weight of the solid. I'm supposed to calculate the weight of the solid in a liquid whose density is 0.9 GCM raised to minus 3. Oh, guys, here there is a twist. I am supposed to calculate the weight of the solid in a liquid whose density is 0.9. So technically speaking, this is W2. Now listen very carefully. Yeah? I have a formula which says that RD is W1 upon W1 minus W2. We use this standard formula, guys, and considering, assuming that the liquid which we are preferring is water. And since that liquid preferred is water, we take it as 1 GCM raised to minus 3. So here we multiply it by 1, but we don't show this part. In this situation, students, there is some other random liquid who's not water. It is something else whose density is 0.9. So guys, my formula will be modified. It will be RD. We will write here RD is equal to weight in air upon weight in air minus weight in liquid which is supposed to be found by its density which is 0.9. RD to I already have which is 10. So I'll write here 10. Weight in air also I found out. I think it is given 32 upon 32 minus WL multiplied by 0.9. Okay. Little bit smartness we will have to do, guys, when we are calculating this thing. This gets multiplied. So this becomes 320 minus, I'm writing it as W2, guys, so that there is no confusion. Minus 10W2 because it will get multiplied with the entire thing is equal to uh, 32 into 0.9. So 320 minus 10W2 is equal to 32 into 9 upon 10. Okay, let's try to multiply 32 into 9. When I multiply, guys, 32 with 9, this is 18, 28. Okay, so I'm writing it as 320 minus the 10W2 is equal to 28.8. This person comes here, this variable goes there, so I get 320 minus 28.8 is equal to 10W2. I can subtract it. 320 minus 28.8 is 291.2. 10W2. Okay, so guys, we will get weight of the object in a liquid whose density is 0.9 will be 29.5. Easy, students. This is the way how we have to solve this question. Okay, clear? Come on, let's take the next set. Today, 14th one is my favorite one. It is a good question, more of application. Let me try to read it for you so that you get a better idea. The question says a jeweler claims that he makes ornaments of pure gold whose relative density is 19.3. Pure gold. That's the reason why it's my favorite. RD is given, jokes apart, guys. RD is given 19.3. He sells his bangle and weighs 25.25 GF when it is kept in air. So technically, students, this is W1. Huh? When that bangle was dipped in water, its value is 23.0.75. So this is W2. We need to find out whether that liquid or whether that bangle is pure or it is impure. So to figure out whether it is pure or impure, I will calculate its relative density. Since we know that students RD is equal to W1 upon W1 minus W2. On doing this calculation, if my RD ka value comes exactly 19.3, means it is pure gold. क्योंकि relative density of gold is 19.3. If it comes little bit up and down, that means it is impure. Let me try to tell you what it will come, guys. They have given us here as a hint, which will not be given in exam, definitely, yes. On solving this thing, your RD ka value will come 11.6, which is not equal to 19.3. So technically, students, this is not an example or this is not pure gold, it is impure gold. Okay, kids. Any confusion, any doubt, guys? Simple, everybody. Fine. Come on. Let's take the next one. So here comes the next question. Question number 15. 15th question is a piece of ice weighs 44.5 GF in air. So this is W1. If density of iron is so and so, so density of iron is given to us. What will be the weight of the object when it is immersed in water? So I'm supposed to find out W2. Guys, I think this is simple, yeah. Come on. Density is given. From this density, I will write this as RD. So this becomes my RD. Remove the unit. We will use the formula. The formula would be RD is equal to W1 upon W1 minus W2. W2 we are supposed to find. W1 and RD is given. Substitute and get your answer. Okay, students? The weight which you will be getting it, that will be in terms of GS. Fine? Come on. Let's take the last question. Question number 16. 16 question. I feel you should help me out, guys. See if you can try. A piece of stone of mass. So mass is given. This is weight 1, 15.1 GS. When immersed in liquid, its weight is so and so. So when it is immersed in liquid, I'm writing here it as W 10.9. When the same stone is immersed in water, so water I write it as W2, this will be W3. What is the weight of the piece of stone in air? This to be just now found. Weight is mg, guys. M is 15.1 multiplied by g, which will be 15.1 gs. Volume, if I want to find out for the piece of the stone, kids, I will use the formula. It will be W2 minus W1. So W2 is water. Oh, I'm so sorry. Here we will write W1 minus W2. Ulta. Because volume will be lesser. So W air, that is weight in air, minus weight in water. Weight in air is 15.1 kids. Weight in water is 9.7. I will get my answer as 5.4 centimeter cube. Relative density of stone. So I think we know this part. Guys, relative density of stone, so we know how to calculate. RD is W1 upon W1 minus W2. Weight in air is given to us, kids. I feel if you see carefully, weight in air is given to us. Uh, I forgot, guys, what was that data? Yeah, it is 15.1. So 15.1. And in water, I think so, it is 9.7. Yeah. I subtract both of them, I get 15.1 upon 5.4. We remove the decimal, we get 151 upon 54. When we will try to divide this thing, we will reach to our answer, which will be 2.79. That will be approximately taken as 2.8 without any unit. Third part is relative density of liquid. Now here I use that formula. W1 minus W3 upon W1 minus W2. W1 is weight in air, W2 is weight in water, W3 is weight in a specific liquid. So students, this will be 15.1 minus weight of the substance in liquid is 10.9 upon 15.1 minus 9.7. Denominator I already know. Numerator, when I subtract, I will get 4.2, which will be technically 42 upon 54. That is 0.77. Guys, one very important part here. In our textbook, W3 ko they have written as weight of water. So guys, please don't get confused. Huh? Like since here, where is my list of formula which we made? Yeah, here. Since here, guys, we are taking W2. We are taking W2 as weight in water, guys. I am keeping that same standard here so that there is no confusion for us. We will assume W3 as weight of the substance in any specific liquid. Huh? Don't go as per the textbook. Like somewhere they have taken it as W2, somewhere they have taken W3, which is creating a confusion. Okay, kids, I hope this is clear to us. Hoping that now you will be more confident when you are going to solve this sums, guys. I have given you the detailing of that sums. I have updated you how to solve the sums. So when you will try, see to that you are practicing them more and more so that the things are becoming much more easier for you. Okay, kids. Thank you so much. Bye bye. Take care. Have a nice and amazing day.